My name is Antonio Mahavon,
And my name is Brandon Ye.
and we are Team General Dynamics Electric Boat, Low Frequency Radio Frequency RF over fiber optics. Our technical directors for this project is Michael Bronner, staff engineer of General Dynamics, and Charles Jewett, engineer specialist of General Dynamics. And our team is composed of myself, Antonio and Mahawam, an electrical engineer, and Brandon Ye, electrical engineer and Chinese major. The motivation behind this project is to potentially develop a RF over fiber communication system that can replace traditional RF coaxial cabling communication system. And this has the potential for improved signal reliability and quality, greater hardware arrangement flexibility, greater signal bandwidth types and link distance, lower signal attenuation over distance, and immunity to electromagnetic interference. It's over traditional coaxial communication systems. And we would like to potentially gain a proof of concept of this low frequency RF over fiber system by first investigating literature relevant for low frequency RF over fiber communication systems and developing a simulation model for this communication system and thus demonstrating the proof of concept. Our anticipated best outcome for this project is to produce a proposal of a prototype of a low frequency RF over fiber system that can replace the traditional coaxial cabling communication systems currently being in use. Since there are no fiber optic products commercially available for communication of low frequencies, is that we are targeting and looking to implement in this kind of system. We would then simulate a prototype system in MATLAB that can model the performance of the fiber optic system, thus demonstrate the proof of concept and performance of the prototype system. From here, I'll hand it off to Brendan Yeh to introduce the company and other details of this project.
Thank you. So, a brief overview of the company that we are working with. So, Electric Boat is a subsidiary of the company General Dynamics. Electric Boat in particular is a primary builder for submarines for the U.S. Navy. And currently, they're the design yard and prime contractor of the Virginia-class nuclear submarine. Okay. So, what is RF over fiber? So, RF over fiber is a method that converts radio frequency signals into optical in order to transmit over a vast distance, where it is then converted back into an RF signal. So, by converting RF to optical, it allows these RF signals to travel across larger distances with minimal signal loss in comparisons to using a coaxial cable. In addition, fiber optic cables are generally more durable, and they offer a higher bandwidth and are immune to electromagnetic interference. So, a brief summary of our key team technical accomplishments towards achieving our company ABO is as a pair, we've investigated literature and technologies relevant to RF over fiber, as well as we have identified design requirements and parameters. We've we've also completed the tutorials for MATLAB and Simulink, as well as identified potential risks to our project and applied the mitigation strategies to overcome them, as well as brainstormed potential design concepts for this communication system. Currently, we have thought of 4 potential solutions, which is the upconversion of low frequency signals for compatibility with existing RF over fiber systems, the lossless repeating of low frequency digital signals by demodulation and remodulation, analog to digital conversion of the received signal, as well as the digital signal processing and encoding. I will pass the microphone back to Antonio to discuss our individual contributions.
Thank you, Brendan. So this is a simple block diagram of a whole kind of architecture of a design for this project, and of the individual technical accomplishments that we'll be presenting in the next few slides. It will be all be towards developing a kind prototype of the fiber optic communication system as a simulation model and potentially as a physical prototype. So far, I have set up team project management site, file share, and Trello board so that me and my colleague and I and collaborate on the development of this project. And then I investigated literature and technology relevant to RF over fiber communications. I trained on MATLAB and Simulink simulation related to communications, and brainstormed potential design concepts for this communication system. Anticipated technical accomplishments for next semester for myself would include development of trade study comparing potential design concepts, proposal of prototype, incorporating selected design concepts from the trade study, simulation development of a simulation model of prototype, and presentation of the prototype. Next, my colleague will present on his own individual accomplishments that for this semester and anticipated for next semester.
Thank you. So up until this point, I have researched and gained familiarity on the following topics: the radio frequency spectrum, current high frequency RF to optical conversion techniques, signal modulation and demodulation, forward error correction, fiber optic cables, MATLAB, and Simulink. And I have also, after completing all of the MATLAB and Simulink tutorials, I've begun experimenting with the toolboxes from MATLAB and Simulink to see what would be the best way to create these simulations. That being said, some technical accomplishments that I hope to achieve before April 16th is I hope to continue to gain more familiarity with the current RF to optical conversion techniques, as well as to review the current these projects and technologies used today, such as their circuit diagrams, their schematics, etc., to hopefully gain enough of an understanding to have a basis to model our simulation off of. And so I also hope to have a completed block diagram in order for us to create these simulation. And so a quick summary of our team future technical accomplishments. We hope to create the simulation model to achieve our AVO, and hopefully have enough time to create and present a real life prototype based on our simulation. So this concludes our presentation. We thank you for listening. We just want to make a quick acknowledgement to our Capstone director, Dr. Harish Sunak, as well as our two technical directors, Mike Bronner and Charles Jewett.